You know the feeling. You're staring at a constructor with like a dozen parameters, half of them are null, and you have absolutely no idea what's what. Well, today, we're going to tackle that exact headache with one of the most elegant solutions out there, the builder design pattern. Let's dive in and see how it cleans up the whole mess of creating complex objects.
So let me just ask you this. Have you ever found yourself trying to create an object and you're just staring at the screen, trying to remember the exact order of 10 different parameters, and maybe half of them are optional anyway? It could be a user profile, a complex report, heck, even just a URL with a bunch of query parameters. It gets really complicated really fast.
And usually, it ends up looking a little something like this. I mean, what does true even mean here? What's that null for? Is the number 4 the number of shelves or the number of drawers? This kind of code is just, it's brittle, it's so hard to read, and it's an absolute nightmare to maintain later on. And you know the worst part? Every time you need a new combination, the problem just gets bigger.
All right, so let's actually put a name to this problem. We're going to call this first section the constructor nightmare. The official technical term for what we just saw is the telescoping constructor anti-pattern. It's what happens when you try to support every single possible configuration by just adding more and more constructors. You know, one calls the next, which calls the next, each with just one more parameter. It is a super common trap to fall into, but thankfully, there is a fantastic escape route.
And you know, this problem isn't just in code, it's everywhere. Think about building a house, right? You definitely need walls and a roof, but that swimming pool, that's optional. So is the 2-car garage. Or think about building a custom PC. You might want 16 gigs of RAM, but no special graphics card. The combinations are practically endless, and for every new combination, you're tempted to add, yep, you guessed it, another constructor. That approach just does not scale. Okay, so enough about the problem. If that's the mess we're in, what's the solution? Let's talk about a much, much better way to build things. This idea right here. This is the core philosophy. It comes straight from the legendary Gang of Four book on design patterns. In plain English, what it's saying is we should separate the what from the how. The process of building something, the steps you take, should be totally separate from the final thing you get. This way, the same set of steps can be used to build a wooden house or a brick house. And boom, this is the result. Just look at how clean and readable that is. You're creating a new sandwich builder. You're explicitly saying you want it with wheat bread, you're adding cheese, you're adding pepperoni, and then you call build. There's zero ambiguity, no confusing nulls. The code basically documents itself. You know exactly what kind of sandwich you're getting just by reading it. It's beautiful. So how does all this magic actually work under the hood? Well, it's not really magic at all. It's just a really clever structure. So let's break down the 4 key components that make the builder pattern really tick. Okay, so first up you have the product. That's the complex thing we're trying to create, like a desktop computer. Second, there's the builder interface. Think of this like a contract or a blueprint of all the steps. Build monitor, build keyboard, and so on. Third, you've got the concrete builder, like a Dell desktop builder. This is the class that actually implements those steps. A Dell builder knows exactly how to build a Dell monitor. And finally, there's the director, which is actually optional. A director is a class that takes a builder and calls the steps in a very specific order to create a predefined configuration, like a standard Office PC. Okay, so we've got the theory down. We know the components. But when do you actually reach for this pattern in your day-to-day work? Let's talk strategy. You want to grab a builder anytime an object has a ton of optional parts, so you can just specify only the ones you need. You should use it when building the object as a multi-step process because it gives you this amazing fine-grained control at each stage. It's the perfect escape from that telescoping constructor nightmare we saw earlier. And, this is a big one, it lets you use the exact same building process to create totally different final objects. Now, it's really important to know the difference between the builder and its cousin, the factory pattern. Think of it like this. A factory is like a vending machine. You push one button and a complete object pops out. It's a one-step deal and it's all about what you get. The builder, on the other hand, is like ordering a custom sub at a sandwich shop. It's a multi-step process that's focused on how the object is assembled, giving you total control over every ingredient. All right, let's bring this all home. If there's one thing you should remember from all of this, what should it be? Let's get to the key takeaway. So why does all this matter so much? Well, for one, readable code is maintainable code. A new developer can look at a builder and know exactly what's happening. You also get incredible flexibility. You can add new options and configurations without ever touching or breaking your old code. And here's a huge bonus. Because you set everything up before the final object gets created, you can make that final object immutable. And that just leads to safer, more predictable, and way more robust code. It's a huge win. So I'm going to leave you with a little challenge. Go find that one messy constructor in your current project. You know the one everyone's a little bit afraid to touch. That is your perfect candidate. By applying the builder pattern, you won't just be cleaning up some code. You'll be making it more readable, way more flexible, and fundamentally more solid. Thanks for tuning in.